What's going on, guys? Let's do this problem right here. The first question is asking, calculate the mole fraction of oxygen gas if 16 grams of oxygen and 7 grams of nitrogen were placed in a container. So let's see how we can calculate this one. So to calculate this one, first of all, I had to get the mole of the oxygen. So how can I get it? I simply divide that by molar mass. So here we have 16 grams of O2. Let's create a fraction, divide by 1, multiply by 1 mole. In 1 mole, so in 1 mole how many grams? It's going to be the molar mass, right? So in this case, 1 oxygen contains 16 grams, so 2 oxygen 32. This is molar mass. This is different thing, right? This is molar mass, gram per mole, and this is for oxygen. So if you calculate this one, you will get 0.5 mole. So we have the mole of oxygen. Then we have to calculate the mole of nitrogen. To calculate the mole of nitrogen, same thing. We have 7 gram of nitrogen over 1. Molar mass of nitrogen is 14. But here we have 2 nitrogen, so it's going to be 28 gram per mole. So we have to put gram into bottom because that's how it will cancel each other, right? Gram cancels, and we have 1 mole on top, and this will give you 0.25 mole. Okay, so the question is asking you to calculate the mole fraction of oxygen gas. To find that, what you have to do, first of all, I have to calculate the total mole. If I add two of them together, that's going to give us a total mole. So 0.5 plus 0.25, 0.75. So x, we are trying to find xO2 equal to 0.75. On top, we are going to have the mole of oxygen, that's 0.5. So this is going to be 0.5 over 0.75. And if you calculate this value, this comes out to be 0.67. And this is the molar fraction of the oxygen. And that answers the first question. Let's move to the second question. The second question is asking the total pressure of a sample containing nitrogen, oxygen, and helium is 800 torr. The partial pressure of N2 and O2 are 500 torr and 200 torr respectively. Calculate the partial pressure of helium and the mole fraction of oxygen. Okay, so they have given the P total, and we have the partial pressure of this N2 and O2. Since we only have these three in the container, like we have oxygen, nitrogen, oxygen, helium. We know two of them already. That is 500 and 200. So let's write it in like an equation first and then answer it, right? So here we have the P total is going to be Pn2 plus partial pressure of N2, partial pressure of O2 plus partial pressure of He. We have two of them, that is N2 and O2. N2 is 500, O2 is 200, and they have also provided the total pressure, that is 800. And now it's very clear that pH is going to be, if you subtract these two of them from this one, that's going to give us the partial pressure of helium. So here we have 800. If you add them together, you will get 700, and partial pressure of helium is going to be equal to 800 minus 700, and that's going to be equal to 100 torr. And this is the partial pressure of helium. That answers the first question. Calculate the partial pressure of helium. And they are asking you to find the mole fraction of O2. Okay, xO2, mole fraction. To find the mole fraction, usually we use this one, right? Total mole of this one over total mole. That's what we use. But when we have pressure, what we have to use? So there's another formula to, like, partial pressure of O2 divided by the total pressure it also gives you the molar mole fraction. So here we have O2 partial pressure that's provided 200. 200 divided by the total pressure 800, and that gives us 1 over 4, and that is equal to 0.25. And this is the mole fraction of O2. And that's how we do this kind of problems. I hope you guys like this video. See you next time.